Begin. Good. Everybody's taking a day off early. Okay, we in this section, section 2.4. Okay, notice we skipped section 2.3. Section 2.3 deals with compound functions, which we're going to do at the beginning of chapter 5. So that's why this chapter only has sections 1, 2, 4, and 5, and we're done. So section 4 deals with symmetry. We've actually talked about this earlier. We talked about this on Monday. Remember what's symmetry? Oh, symmetry. What is symmetry? Symmetry is actually a reflection. If you think about it, if there's a line, and if I draw a circle, a half a circle here, and I draw half a circle there, those are symmetric because they're equal on both sides. So symmetry means a reflection. It's a mirror image on both sides. Now, we say about an axis. So let's say this is the y-axis. So this is symmetric about. That means it's on both sides of that axis. Two main axes are the x-axis and the y-axis. And what we're going to talk about here is going to be very important in the next section also. So here's the x-axis, and that's the y-axis. The x-axis and the y-axis. Can you think of a function that's symmetric about the y-axis or x-axis? Well, first off, it's not a function because you can't have two of the same x's. But can you think of an equation that is symmetric about the x-axis? In other words, I could flip up and down. But not an equation. I'm a general equation. Well, what picture can you think of? Well, the same picture I'm thinking about right now could be good for both of these. Think of a circle. Well, yeah, because if it's, let's say this point here is at 2 and this is 1. If it's symmetric about the x-axis, that means there's a mirror point on the other side of the x-axis. What would this point be down here? That would be -2, right? Because it's the same distance. The same distance. What's the location of this point? 1, 2. It's a point. Remember, it's a point, so it has to have an x and y component. What's the location of this point? So what do we notice about symmetry about the x-axis?
That the x value is the same, but the y value changes.
Changes what?
The
Changes signs. All it does is change sign. Symmetry about the x-axis means 1. X values are the same, and the Y values change signs. All it does is change sign. It doesn't change anything else. It just changes the signs. So that's symmetric about the x-axis. If something is symmetric about the y-axis, if it's symmetric about the y-axis, what's this point going to be? This would be -2. So this location would be +2, +1. And this one is so what do you notice about symmetry about the y-axis?
X values are unified.
Yeah, yes. Symmetry about the y-axis means 1, the y values are the same, and now the x values change signs. So just backwards. Yeah, exactly. It's exactly opposites of each other. But if you think about it, the x values here are the same, the x values change sign. Here. So, and it's just now basically what it means to be reflective. If you fold on the x-axis, remember the same. If you fold on the x-axis, that means the top half is the same as the bottom half. That's symmetry about the x-axis. If you fold it on the y-axis, if you fold it left and right, it's going to be a mirror image there. So far, so good. So those are only 2 of them. Those are the main axis. There's a third one. Now, actually, what else can we say about these? Is this going to be a function? Because remember, the function has a vertical line test. You cannot have 2 x's to the same y. Has to be 1 to 1. This is a function. Because any vertical line I pick, each x only goes to 1 y. Because not a function, because 1x goes to 2 y's. Here, 1x goes to 1 y. The vertical line test. Now, since this is not a function, we don't have to worry about it because there's not too many not too many graphs or equations that we're going to deal with that will look like this. But if it is symmetric about the y-axis, it's got a special name. Remember, it is a function. What kind of function is it? We say this is an even function. So if we flip across the y-axis, then it's an even function. Because the only thing changes are the x values change signs. The y values stay the same. So that's an even function. We'll look at those. We'll look further at what that means in a minute. All right. So this is how on the main axes, the x and y axis. There's another axis. There's another reflection. Then the second is a reflection about the origin. We still use a circle. So if we had a point here, let's say at 2 and 2, remember, when we say reflected, that's the part where we fold the paper. So here, we're going to fold the paper across the origin. That's where we're going to fold it. So then what's on the other side? What's the location at that point? Hmm? You're asking me. I'm asking you.
-2.
-2, -2. Because remember, what quadrant is this? It's quadrant 3. What are the characteristics of quadrant 3? They're both negative. This is quadrant 1. What is its characteristics? So to be symmetric about the origin, symmetry about the origin the x values change signs and the y values change signs. And there's another one for symmetric about the origin. What about if a point is here? Let's say that's at 2 and this one's at -1. This is about the origin. What if I fold it like this? What quadrant is this? What is its characteristics? Let's try again. Positive, negative. So what is the opposite of that one? The reflection of that one? What quadrant? Quadrant 2. What is its characteristics? Yeah, see, so remember, like it says up here, x changes signs, y's change signs. So that means I'd have a point over here. So far, so good. And we say this one is symmetric about the origin. What that means, it flips across the 0, 0, the middle. So if you notice, it flips across. It has to go through that point. So if I'm going from this point to that point, I have to skip over that, gets to the other side. Likewise, these. This one is called symmetric about the x-axis. What's this one going to be called? Right. Symmetric about the y-axis. So those are pretty easy. How do we find those mathematically?
By having it.
Well, if I give you a function, an equation, how would you prove to me which one of these three it fits? In other words, if I give you this equation, let's test for symmetry about x-axis, y-axis, origin. Oh, I also forgot another thing when you finish writing this down. Remember, if it's symmetric about the y-axis, what's another name? What kind of function is that? Look at your notes. If it's symmetric about the y-axis, it's an even function. If we have an even, then we have to have an odd function. If it's symmetric about the origin, then this is an example of an odd function. So even function flips across the y-axis, an odd function flips across the origin. So let's see. One, how do we test about the x-axis? How would we test that? What do we have to do? Well, what this thing says, to test if it's about the x-axis, the x values have to remain the same and the y values have to change signs. So let's test that. So in other words, what that says, if I put x equals, let's say 2 in there, if I put x equals 2, what does that equal? Okay, so I have a 0.26. Now, this he says, the x values change signs. Do the y values, or the x, I'm sorry, the x values are the same? Do the y's, can y change to be -6 if I use the same x value? Yeah, remember what this thing says. Remember what this thing says, to be symmetric with the x-axis, the x values have to be the same. Can I get a different y value? Can I get a -6 if I use the same x value? No. So it's not symmetric about the x-axis. Simply because this is not possible, not symmetric about the x-axis. Because there's no way I can make it happen. Now we'll try the y-axis. We're supposed to check all three of them. So let's test symmetry about the y-axis. So what has to be true about the symmetry about the y-axis? Yeah. Do I get same y, different x? So let's see. If I have x equals 2, that equals 6. So we have a point 2, 6. If I put -2 in there, if I put -2 in there, what is that going to equal? Are they the same values? No, I put -2 in there. So it's not this. No, it's not symmetric about the y-axis, because to be symmetric about the y-axis, I have to have two different x's, but the same y value. So I have check. I have two separate x's, two different x's. I change the signs on them, but the y values are not the same. So it's not symmetric with the y-axis. And what's the third one I gotta check? I check about the origin. So for the origin, what has to be true there? X and y change signs. So let's see. If I put 2 inside there, my y becomes 6. If I put -2 in there, y becomes -6. Check. So this is symmetric about the origin. That's how you test it. But it also helps if you know the graphs. Again, if you memorize the library of functions, this would be a lot easier for you. What kind of graph is that? What kind of equation is that? It's linear. If you have an x and a y in there, it cannot be horizontal or vertical. It has to change, right? So this one, since it doesn't have a y-intercept, it has to cross through the origin. So that's what it looks like. Obviously, it's going through the origin, so these points have to be opposite of that. So it's symmetrical at the origin. Again, that's why I said memorize library functions. How about this function? Is it symmetric about the x-axis, the y-axis, or the origin? I talked to Greg Morris, the number 2 guy in the district, and he said, tell him to call me now.
I just left off. He called as well.
Good.
But I mean,
No, it does matter because Greg was livid. It was after graduation.
oh, he emailed, Don Trell emailed me yesterday telling me to be out of my office by Friday. It's the first time they've communicated anything to me.
Talk to the number 2 guy because
Well, like I said, Dr. Fernandez, called him while I was there. I just got out of a meeting with him. I mean, I'm out. It's fine. It is what it is.
No, it's not because then
those people need to be helped.
and that's why you have to talk to Greg. That's why you have to talk to Greg. He's the number 2 guy. He's 100% in your sight.
But yeah, I was walking by. I was like, "Is that Arthur?" It is Arthur.
All right. So back to this. How do we check for x-axis? For x-axis, the y's have to be the different for the same x. So if I put the same x in there, can I get 2 different y values? Can that change? If I put x equals 2 again, will I get a different answer? No, this is as far. So it's not symmetric about the x-axis. Well, we knew that. We knew it's not symmetric about the x-axis because if it's symmetric about the x-axis, it's not a function. Is this a function? Yes, it's in our library of functions. It's in our library of functions. So we knew this one cannot be symmetric about the x-axis. How about the y-axis? If it's symmetric about the y-axis, then we have to have the same x's but different signs. So let's see. If I put x equals 2 and I put x equals negative 2 in there, do I get the same y value? Y equals 2 squared. What is 2 squared? Y equals negative 2 squared. What is negative 2 squared? 4. They're the same. These are different. So yes, it's symmetric about the y-axis. Again, this is the way you test it. Can you pick, if I put the same value in there, if I put x equals 2, x equals 2 in there, will I get a different answer? No. Because I can't, so it can't be across the x-axis. If it's a y-axis, I got to pick the same value but different signs. Do I get the same answer? Yes. So that's how you test symmetry about the y-axis. Now let's try about the origin. How do you test about the origin?
Are-
Well, they have to have different signs. So we know if we plug in x equals +2 and -2, does y get different signs? No, we just did that. So it can't be, it's not symmetric about the origin because these are the same signs. They have to be different signs. Is this one symmetric about the x-axis, y-axis, or origin?
Oh,
What else could it be?
sorry, it's a little bit tricky.
That
No, it's X. The cube, yeah.
Oh, y equals, I'm like, what is that in the middle?
That's-
Yeah, it's like a two.
I don't know what that was.
what else? What other symbols have we used so far? I mean, every one of them is y equals. So, is it symmetric about the x-axis? Why not? What do you test there? Right. So, if I plugged in 2 inside there, what's y going to equal? Try again. Try again. 8. Plug in 2. What does 2 cubed mean? 2 times 2 times 2. Doesn't mean 2 times 3. It means 2 times 2 times 2. So, is there anything, can I ever get a different answer? No. So, it's not symmetric with the x-axis. It is what it is. Is it symmetric with the y-axis? Can I put in 2 different x's? Do I get the same answer? If I put in -2, what do I get? What's that? -8. If I put in +2, what do I get? So is it symmetric with the y-axis?
Oh, no.
You have to stop answering so fast. You have to start taking time and think about what I'm asking. Yes, so it's not about the y-axis either, because you have to have different x's but the same y's. Is it symmetric with the origin? It is different. Because this is negative, that's positive, negative, positive. Yep. As long as the x's are different and y's are different, it's different signs, it's around the origin. Odd functions versus even functions. How do we know if it's an odd function? Yep. Symmetric about the origin, which means xy also has a point at negative x, negative y. How about an even function? Very good. It's symmetric about the y-axis, which means what? That means xy has an equal point at negative xy. Yes, I could go on and make you go through all the tests we just did earlier to determine if a function's odd or even. Because what they want is plug in this different x values. Do you get different y values? Plug in different x's. Do you get the same y value? There's an easier way than that. Let's first look at some examples. And then I'm going to give you the answers of what they are. All right. Here's the first example. Is that odd or even? Even. How do we know it's even? But what does that mean? Why is that even? You're just saying that the exponent is even. What about this one? Is that odd or even? Or neither? Why is it even? Again, you can't just read right now, unless you can prove to me, you can't really just look at it and tell me. You haven't done any work yet to see if it's true or false. Okay. So why does that make it even? All right. So we'll go with that right now. How about this one? Is that one odd or even or neither? It's no longer a parabola. A parabola is that. That's a parabola. X squared. I didn't say it yesterday, did I? When we talked about x squared, it's no, that's a parabola. If it has a power two. So is this odd, even, or neither? It's what? I don't probably it's either yes or no. It's mathematics, it's either right or wrong. That's an example of an even one. How about this one? Odd, even, or neither? You're guessing. That sounds a question. How would you go about if your life depended on it? How would you go about prove this one? If you graph it, what would it look like? What's the graph of this one? Yeah, it's a diagonal line. If x is 1, y is 1. When x is 2, y is 2. When x is -3, y is -3. So is it symmetric? About which axis? About the origin. So that makes it odd. Symmetric, if it's even, it's about the y-axis. If it's odd, it's about the origin. How about that one? Again, this is math. You have to have a proof, a reason for your answers. Did anybody graph this one? What's the graph going to look like? It's a horizontal line. It's y equals 2. So it has to go through 2. So at this x, is it same as this one? Yes. So it's an even function. How about, well, no, how about that one? Odd, even, or neither. It was odd. How about that one? That one's neither. How about that one? Actually, those 8 should be enough to look at those 8 that we wrote down. You should have been writing these down, by the way. What can you see? What pattern do you see forming with these 8? Write them down. All right, you look at the board all the time. Write these down and look for a pattern. So what do you notice? What's the only thing different between all these? What changes in all these? No, signs are irrelevant. The degrees. Well, not the degrees, but all the exponents. The signs are these guys. Those have nothing to do with it. Okay, so again, I'm asking you here. I'm going to give you 2 questions here. These are example 3. Tell me your final grade depends on these answers. Tell me if it's odd, even, or neither. With what we talked about up here. And don't guess. I don't want any guesses. If you guess automatically, you're not a mathematician. You're not even a detective of any sort. So what's the first one? Odd. Why is it odd? All the powers are odd. What about this one? It's even because the powers are even and we have a constant.